We've spent the first two sections talking about how you graph quadratics and how you graph polynomials. Now what we're going to talk about is how you can decompose a polynomial by specific division properties. And the first thing we're going to talk about actually has roots with when you learn how to long divide a number. When you learn how to long divide a number, you have a few placeholders, and the idea is you see how many times this number goes into whatever number it is first. How many times 10 goes into 13. And you repeat this process by carrying down the next term, and you do this, and then you have when you first learned this, you had a remainder of 5, and you did this, you had a remainder. What we're doing today in this section is very similar, except we're dealing with algebraic expressions rather than numerical expressions. So what we're going to do is we're going to divide this expression by another expression. So what you're going to see is, and I'm going to put this off to the side here because we're going to need room for this because this is a lengthy process. I'm going to take this expression and divide it by x minus 2. So when you first do this, what you have to ask yourself is, how many times does your lead term divide into the lead term that you're dividing into? So I'm dividing x into 6x cubed. So if I do that, how many times does that divide evenly? Well, that divides in evenly 6x squared times. You divide into that. Then you take this expression and multiply it to see how many groups that you have. You get 6x cubed minus 12x squared. Now I have to subtract this group from the entire expression. So these two things cancel out. And negative 19 minus a negative 12 is a negative 7x squared. From here, we carry down the next term. And we repeat the process, except now the lead expression, or term in this expression, is this. So we're dividing x into this. So I'm taking negative 7x squared and dividing that by x to see what I get. And what I'm left with is a negative 7x. So I'm going to take both these terms and times them by negative 7x. So I get negative 7x squared plus 14x. So then from here I'm going to subtract this group. These two things cancel out. I'm left with 2x minus 4, and I repeat the process one more time. Divide x into 2x. That is a positive 2 times. I get 2x minus 4. Subtracting these two groups, I get 0. I have nothing left to divide into, so when I divide this expression by x minus 2, my answer is this. Now it says use your results to factor the polynomial completely. Okay? When you divide something, and I'm going to talk about this a little bit more so we know how to complete this answer, I'm going to check to see if this expression is factorable. So I'm going to put 6x squared there. 2, I'm looking for numbers that multiply to 12 and add to negative 7. That's a negative 4 and a negative 3. These two have a negative 1 in common. These two have a 2x in common. These have a 3x in common. These have a negative 2 in common. So this expression here factors into 3x minus 2 times x minus 1. Now, what we're going to talk about later is that this, when you divide into something, this is a factor. So the complete factoring of this would be x minus 2, 3x minus 2, x minus, excuse me, this is 2x minus 1. 2x minus 1. Now I'm going to talk about this more in detail, but we know how to factor. The process that I'm talking about just for now is the long division part in detail. Now, Another problem that you're going to run into when you do long division is the same problem that you deal with when you do long division with whole numbers. As you can see here, we have an x cubed. So that's the leading degree. It's a third degree, and then we just have a constant term. So we're missing some things. When you have something and you're dividing, you have to make sure every single placeholder is accounted for. Because when you long divide numbers, if I divide 10 into 1,000, I don't just put a 1 there. I have to account for every placeholder. When you're dealing with long division, you have to account for all placeholders with expressions too. So there's no x squareds and there's no x's. So you have to account for all the placeholders. And now we have all the placeholders accounted for. We can deal with the process of dividing everything. So I'm going to divide the lead term by this lead term, and I get x squared. I'm going to take this x squared and times it by these two things. I get x cubed minus x squared. I'm going to subtract the two things, and I get a positive x squared plus 0x. Now I'm still going to carry down this term because we're going to see something happen when we divide it into it, because it divides, this x divides into x squared x times. So I'm going to times these. I get x squared minus x. Again, I'm going to subtract these two things. So I have 0x. Since those cancel out, I have 0x minus x. It's a positive x minus 1. I divide x into x. It divides in one time. You times these two things together, I get x minus 1. And I subtract that. Nothing left. So this divides evenly. This is a evenly divisible expression into this one. So my answer for this is x squared plus x plus 1. Now I'm going to talk about how you divide something and you run into a problem when it's not in the right order. So you see everything's written in the wrong order and there's missing placeholders. So I'm going to account for that. The first one is the 2x to the fourth. There's no x cubed, so I'm going to put 0x cubed here. Then there's a negative 5x squared. Then there's a positive 3x. Then there's a minus 2. So we're dividing by, and this is in the wrong order too, and the placeholders have to be in this as well. They have to be in this expression, what you're dividing by as well. X squared plus 2x minus 3. The same process is going to happen here, except now we're dividing in 3 terms. So the lead term is going to be divided by this lead term. So I divide into those. It becomes 2x squared. I times this by 2x squared. I get 2x to the fourth. 2x squared times 2x is a positive 4x to the third. 2x squared times a negative 3 is a negative 6x squared. So I took this term and multiplied it by all of these. Now I'm going to subtract all of this. So this cancels out. 0x cubed minus 4x cubed is a negative 4x cubed plus x squared. Because it's a minus a negative, it becomes a plus x squared. Then I carry down the next term because we have 3 terms here. So I'm going to divide this one into this 4x cubed, this negative 4x cubed, into x squared, and I get negative 4x. I take negative 4x times all of this. I get negative 4x cubed minus 8x. Then the negative 3 times the negative 4x is a plus 12x. So I combine all of this. I subtract it. I get 9x squared minus 9x. I bring down the negative 2. And then I repeat the process again for this one. So I divide x squared into 9. And I get 9 as well. So 9 divides into this. I get 9x squared. So it's 9x squared And then I take 9 times the 2x, and I get 18x. Then I take 9 times the negative 3 to get negative 27. So I subtract all of this, and you're going to see that they don't divide evenly anymore. We have something here. We have negative 27x plus 25. I have nothing else to carry down. So this is a problem. Okay? We have nothing else to carry down. This doesn't divide evenly into this. So when you're done dividing and you're left with something that doesn't divide even, this is a remainder. And when you deal with remainders, the first thing that you usually did was just write remainder 5. But when you deal with this in terms of division, a remainder is always what you're left to divide by. So I am left with this negative 27x plus 25, and I can't divide this anymore by what we're dividing by, so I just write it as this expression over what we're dividing by. And that's all the further that you can go with this. Whenever you have a remainder, you write the remainder over what you're dividing by. So what you're dividing by is going to be, the denominator has to be what you're dividing by. So that is your divisor, or what you're dividing by. So because we didn't have anything left to bring down, and you can't divide this lead term into x squared evenly, that becomes your remainder. Now, the next part that I'm going to talk about, I'm going to take a few minutes to explain a couple of things. If you are clever enough, and people that have done this long enough found a way to make this work a lot easier, if you notice with dealing with linear terms that there's a specific process that comes involved, there's always some subtraction, there's always some multiplication, and you're always dealing with specific numbers. When you are dividing, by a linear term, there is a much quicker process that goes through the entire steps of long division that you would do in a quick numeric pattern. And this is called synthetic division. Now, we talked about this very briefly last year in Algebra 2. And the idea behind this is that you are going to line up your coefficients. And these coefficients are actually the part that make the most, are the most important for when you do long division. So as long as it's in standard form, we're going to line up the coefficients, and then we're going to perform a couple simple operations, and we'll come to a straightforward answer very quickly. And in the next video, I'm going to tell you how to do this.